Okay, we are going to look today now at solving radical equations. The operations, we know how to add and subtract and multiply and divide, or at least we're learning how to do those things. And so now we're going to get to how do we solve stuff that involve radicals? Okay. So solving square root equations, one thing we want to do is to isolate. Okay, get it alone, the radical. So get that radical expression by itself, or it could be, doesn't have to be a radical expression, it could be something raised to a fractional exponent. And get that by itself on the side of the equation. Second step is to raise each side to the power suggested by the index, and we'll see what that means as we're working through these. And then lastly, make sure you check your results for extraneous solutions. You guys remember what an extraneous solution is? It's like you do all the work correctly, but that solution still doesn't work, and so you have to check it. We did that with rational, with we had fractions. We got a solution, and then we plugged it back in, and we had to throw it out because it made you divide by 0 or it didn't work out. The reason here, the reason it may not work is you may get a solution and you plug it into a square root, and you end up getting like the square root of 2 equals negative 2. Or square root of 4, sorry, square root of 4 equals negative 2. And you know something like that's not true. So we'll see those come up. Right, so let's look at this first one. So 2 times the square root of x minus 5 equals 3. So following those 3 steps, the first step, we isolate that radical expression. Get the square root of x by itself by adding 5 to both sides of the equation. And we get 2 times the square root of x is equal to 8. And then divide by 2. And we get the square root of x is equal to 4. Okay, so that's step 1. Step 2, raise each side to the power suggested by the index. So here, what's the index? 2. And so raise both sides to the power of 2. Because when you square the square root, you're going to get just x is 16. All right, and then step 3, check just to make sure it works. Okay, so we're going to check here. So if x is 16, then when you check, you go back to your very original problem. So does 2 times the square root of 16 minus 5, is that equal to 3? Well, that'd be 2 times 4 minus 5, and that's 8 minus 5. So is that going to work out? Okay, so that's a true statement, and so because that's true, we're going to keep our answer. Okay. But it's important with these kinds of problems to check because sometimes you'll do great work and it won't work. Okay. So the second example, first step, a question, yeah. What does yours say? Let's go with yours. Okay, so yours is, let me just copy it down. 10 minus 2x. Okay. So here we have 2 square roots. Okay, so step 1 said to isolate the radical. Well, we got 2 radicals, and you can only isolate one. And if you isolate one of them, that's good enough. And that's what we've done here. We've isolated one of them. Okay, so step 1's already complete for us. Step 2, raise each side to the power suggested. So it's a square root. We want to square both sides. When you square the left side, gets rid of the square root, and you end up with 10 minus 2x. When you square the right side, what do you think you get? Okay, good. So make sure you square the 3, right? 3 squared is 9. And then times 2x. Good. Just So when you square the 3, you get 9. When you square the square root, they kind of cancel each other out. You just get the 2x. And so now we have 10 minus 2x, 18x. And we solve for x. So I'm going to add 2x to both sides and get 10 is equal to 20x. And then divide by 20, and you end up with 10 over 20 is x, but that's just x equals 1/2. Let's check to make sure that works. So is the square root of 10 minus 2 times 1/2 equal to 3 times the square root of 2 times 1/2? Well, 2 times 1/2 is what? 1. So that would be the square root of 9, because 10 minus 1 is 9, is equal to 3 times the square root of 1. True or false? That's true. Okay. So we keep it. Okay. So try this one here. Try 7 plus 3 times the square root of x minus 1 equals 1 by following those 3 steps. Okay, so we isolate, step 1, isolate the square root. By subtracting 7 first, you end up with 3 times the square root of x minus 1 is 1 minus 7, which is negative 6. And then divide by 3. And you get the square root of x minus 1, negative 2. And then, so that's step 1. Step 2, you square both sides. And you end up with x minus 1 is positive 4. And then you solve. And you get x is 5. And then you check it. 7 plus 3 times the square root of 5 minus 1. Is that really equal to 1? Let's check. So 7 plus 3 times the square root of 4. 7 plus 3 times 2. Is that going to equal 1? You can already tell it's not going to equal 1. So this is a false statement. So we got to throw out that answer. Okay. So there's no solution because that was the only possibility and we threw it out, so there's no solution. Okay. Now, we could have recognized earlier that there was no solution. Anybody see at what step we knew that there was no solution? When you have a square root on one side by itself, it can only equal a positive number or 0, right? And we had the square root of x minus 1 is equal to negative 2. So at that point, at least to me, it was triggering, okay, there's something wrong here. We're going to get no solution. And we saw that. So if you didn't recognize that there, that's fine. But that's why it's important to go and check to see if your solution is an extraneous solution or not. Okay, so try it again on the next one. On this next one, we want to get the radical by itself. Okay, that's your step 1. And we do that by subtracting 3. We get the square root of 5x minus 1 is equal to x minus 3. Then second step, we want to get rid of the radical. In this case, it's a square root, so we're going to square both sides. And on the left side, we end up with 5x minus 1. On the right side, we need to multiply it out. We need to find out what x minus 3 times x minus 3 is. Okay, it's a binomial. You have to distribute that. So let's do that. We get 5x minus 1 is x times x, which is x squared, x times negative 3, negative 3 times x, and negative 3 times negative 3. Okay? So now we've got a quadratic on our hands, and so we got to handle this a little differently, use some of the quadratic methods to solve this, which is typically we make this equal to 0 and hope it factors. If it doesn't factor, we use the quadratic formula. Okay? So I'm going to first combine the negative 3x's and get 5x minus 1 is x squared minus 6x plus 9. And then I want to make this equal to 0, so I'm going to subtract 5x and add 1 to both sides. So on the left side of the equation, we end up with 0 equals x squared minus 11x plus 10. Now we look to factor this. This is a quadratic with a 1 as a leading coefficient, so we ask ourselves what two numbers multiply or have a product of 10 and have a sum of negative 11. Negative 10 and negative 1, right? Multiply to positive 10, add this. Okay, so this is going to factor to x minus 10 times x minus 1. Set each factor equal to 0, and we'll get two solutions because we have two factors. X is 10, and x is 1. How many got that far? Okay. Now we got to make sure we can keep those, right? And sometimes you can keep both of them. Sometimes you can only keep one. Sometimes you have to get rid of both of them. So you have to check both of them. All right, so let's check when x is 10. So square root of 5 times 10 minus 1 plus 3 equals x, which would be 10. Let's see if that's true or false. So we get square root of 49 plus 3 is 10, which is 7 plus 3 is 10, and we could see that that's true. So we get to keep that one. And then let's check when x is 1. Here we get the square root of 5 times 1 minus 1 plus 3 is equal to 1. Now I'm already guessing there's going to be problems here because we're going to do something positive plus 3 equals 1. Not sure how that's going to work out, right? But let's go a little further on this. So 5 times 1 minus 1 is 4. So this is the root 4 plus 3 equals 1, or 2 plus 3 equals 1. We see that's false. So we need to throw out that solution. That's what we call an extraneous solution. We can only keep the x equals 10. So sometimes you'll have a quadratic and you have to use the factoring or the quadratic formula for that. Okay. Try both of these now. Do two of them. Okay, the first one, 2 times square root of x minus 5 minus 3 equals 7. Did we get a solution to this one? What are we getting? X equals 30? Yeah, how many got x equals 30? Right, so let's check that. First step, get the square root by itself by adding 3 to both sides of the equation. And then dividing by 2. Second step, get rid of the square root by squaring both sides. And you get x minus 5 equals 25. And then last step, well, we solve for x. We get x is 30, and then just to check, make sure it's not an extraneous solution. So 2 times root 30 minus 5 minus 3, is that 7? Well, that's 2 times the square root of 25 minus 3, or 2 times 5 minus 3, or 10 minus 3. And we could, oops, got to fix something here. So we see that 10 minus 3 is 7, so that's true. So we get to keep our answer, and we're ready to go to the next one. Okay. How about the next one? Did we get an answer? What answer? X equals 5 and 2. You get to keep them both? Just so some of us think we just get to keep 5. Some of us think we get to keep both. What do you say, Kale? Neither. You don't get to keep either of them. Okay, so let's see what happens here. So first step, get the square root by itself. Already done. Second step, get rid of the square root by squaring both sides. So the left side we end up with x minus 1. Right side we need to find x minus 3 times another x minus 3. So we distribute x times x is x squared minus 3x minus 3x again plus 9. So I'm going to combine the negative 3x's. Get negative 6x plus 9. And then because it's quadratic, because we have an x squared, we want to make one side equal to 0. I'm going to make the left side equal to 0 by subtracting x and adding 1 to both sides of the equation. So 0 is x squared minus 7x plus 10. And now we try to factor this. We're looking for two numbers whose product is 10 and whose sum is negative 7. Is that possible? Yeah. Negative 2, negative 5. So this factors to x minus 2 times x minus 5. Set each factor equal to 0 and solve, giving two answers, 2 and 5. And now we get to find out, can we keep them both? Do we have to get rid of one of them? Or do we have to get rid of both of them? So let's check. If x is 2, we get the square root of 2 minus 1 is equal to 2 minus 3. Well, that's the square root of 1, and that's negative 1. Is that true or false? False. When you take the square root of 1, you should get positive 1, not negative 1, so that's false. And so we need to throw out the 2. Okay, let's check the 5. Here we end up with the square root of 5 minus 1 is equal to 5 minus 3, or the square root of 4 is equal to 2. True or false? True, we get to keep that one. Okay. So if you said x equals 5 is the answer, you're right. Okay. Questions? Okay, the last two are similar, but they just start off with as two functions and doing operations with functions. And so we just need to set up these equations as given here. So f of x is the square root of 2x plus 8. And we want to subtract g of x from that. G of x is x, and that equals 0. So that's what the first equation would look like when we follow the directions here, because we're plugging in equations for both f of x and g of x. On the next one, that notation f of g of x equals 24, that's saying take g of x and plug it into f of x. We say that's a composition of functions. And when we do that, g of x is x plus 2, and we want to plug that in or replace the x in the other equation with x plus 2. And when we do that, surround the x plus 2 with parentheses. So what's that going to look like? 3 times x plus 2 in parentheses to the power of 3 over 2. That's your f of g of x. And remember, that's equal to 24. Okay, so the first one kind of looks like what we've been doing, right? The second one looks a little different. But you can still solve it following those three directions, the 3 steps. Okay? And so again, I'm going to give you a little time to try to solve both of these. All right, so we are running low on time, so let me go over these. First one, isolate the square root. We got square root of 2x plus 8 equals x. Second step, square both sides. You get 2x plus 8 equals x squared. Third, well, and then we want to solve for x. So we want to get, because it's quadratic, make one side equal to 0. And I'm going to do this by subtracting 2x from both sides and subtracting 8 from both sides. Then I work on trying to factor this. Does it factor? Can we come up with two numbers that multiply to negative 8 and add to negative 2? Okay, negative 4 and positive 2. So that gives us x equals 4 and negative 2. When we check those, do they both work out? So if you have square root of 2 times 4 plus 8, is that equal to 4? And we get square root of 16. That's true. So we keep the 4. When we try the other one, we end up with what? The square root of 4 equals negative 2, sorry. And we know that's false, right? So we throw out the negative 2. Okay, so x equals 4 is the answer to the first one. Okay, on the second one, get this part alone by dividing by 3, and you get x plus 2 to the 3 halves is equal to 24 divided by 3, which is 8. And then we want to get rid of the 3 halves power. Here's the trick. What do you multiply 3 halves by to get 1? So raise both sides to the 2/3 power. When we do that, this becomes 1, and you just get x plus 2 equals 8 to the 2/3 power. Now remember what 8 to the 2/3 power means. It means the cube root of 8 squared, which is 2 squared, or 4. So this really reads x plus 2 equals 4. Okay? And you subtract 2, and you get 2. And try it out. And you find that that's true, and you get to keep it. All right, guys, have a great weekend.